Yeah, so for this sampling and testing, right, all that you need to focus on is really just this first formula, unbiased estimate of population variance. Okay, then you just need to know how to use these two versions of the formula. Typically, you will be using this version. But do you have a copy of the MF26 with you right now?
Yeah, have.
Okay, go and find it. Shall I wait?
Yeah, I have. Sure.
Okay, then what I want you to write down is the alternative formula. This is not in the MF26. I want you to write this down. It's 1 over n minus 1 multiplied by, instead of summation. Oh, by the way, don't write it as a sum like that. Write it as a horizontal and try to make it more horizontal and sharper.
Oh,
Also, by the way, for expectation of x, also must be capital E, don't curvy. No, that one is epsilon already. Different letter. Don't write it that way. Okay? Yeah, sum. That's small letter. This you need a capital letter. Okay, anyways, the formula that I have for you is x minus a bracket square minus away sum of bracket x minus a bracket around the entire sum, then square, divide by n, close bracket. Basically, everywhere that had a x, you replace it with x minus a. Is that okay?
Yeah.
This is the hidden formula that you should know that will not be provided, but you can just use it. No, don't need to prove. Okay? You will need this in the example I'm about to go through. Oh yeah, should I also mention, since we're at the MF26, there are some formulas that are not available over in the MF26 that you're supposed to already know, right? Some of them is like the trigo sine square theta plus cosine square theta equal to 1, as well as the other two versions. If you divide by sine square, divide by cosine square, it's not provided anymore. You need to remember how to do it. How to recover it yourself, or just memorize. The alternative way is to just remember sine square plus cos square equal to 1, then divide by sine square. And the other guy is to divide by cosine square. These are the things that are not in the formula list. You need to memorize. Okay. Anything else I should take note of? Yes. Then here is fx. There is f prime x, right? That's the derivative. But of course, if you want to integrate, that just means you can also work backwards. If you integrate this, you'll get back to sine inverse. Integrate this negative one, you get cosine inverse. Is that okay? So on and so forth.
Yeah.
Can and anything else I should take note of? Yeah, over here, this fella. Okay, this binomial expansion technically is no longer in your syllables. This formula is for the case where n is a non-positive integer, like a positive but still rational. You can use it. No, can be negative as well. Rational. It's in general when n is a rational number. This formula will work, but it is no longer in your syllabus. You only need to focus on the first version. A plus b power n. But what you also realize is that n choose r, they give you a formula here, but it is equivalent to this guy over here. Okay, they are the same. So you can use either version if you like. Okay.
Okay.
Yeah, just a thing to take note. Then anything else? Okay, there may be some other things, but we'll talk about it next time. Yeah, we'll talk about it some other time. Oh, right, cross product. Yes. Here they gave you the A3B1 minus A1B3 version. I think it's better if you remember it as negative of A1B3 minus A3B1. Reason is because it follows the same left minus right pattern. Do you know what I'm talking about? Like to get the second rows, you cover up this first row, and then you crisscross like that.
Yeah.
A1 times B3 minus B1 times A3. A1 times B3 minus A3 times B1. And then bracket, put an extra minus. I think it's easier to remember that way instead of this guy. Okay?
Okay.
Can I? Yeah, okay. Back to sampling. Oh, not this one. I want the sampling example question. Yes, here. Okay, have you read this question? I didn't assign it.
Oh, I haven't yet.
Okay, let's read it now. Quite easy. Now, past records show that on average, the wage that each worker received was $30. You hear the word average, you must think X bar, okay? Or something along those lines. The Ministry of Manpower wants to find out if there is a change in the mean daily wage of workers. The daily wage received by a worker is denoted by X dollars. Data from 60 workers are randomly collected and their wages are summarized as shown below. X bar is 31. It's not 30. Then summation of X minus 31 bracket square equals to 1947. Version 1, calculate the unbiased estimate of the population variance. Here, this, do you know what's the difference between this 30 and this 31? Do you understand the story? Like roughly explain to me what's going on.
Oh, the 31 is the average within the 60 workers only.
Correct. Then the 30 is?
The 30 is like the everybody, like it's X bar.
I think that's the population mean, right? That's what you mean?
Yeah.
And this guy is the sample mean.
Yeah.
Okay. Do you know the difference between sample and population, right?
Yeah.
Sample is just a subset of the population, huh? So yeah, this is the true mean. This one is just the sample specific to these 60 only. Okay, so when you want to calculate unbiased estimate, do you focus on 30? Not at all. Never look at the population. Just focus on these two fellows and then calculate. Okay? Can
Yeah.
So here I gave two versions for the question. Okay, version one. This part is these two pieces of information are given. I want you to calculate unbiased estimate of population variance. Do you want me to go through, or I let you try?
Can go through.
Yeah, better if I go through. You can try on your own later, huh? It's recorded anyways. Right. Then later, just explain first. Now there's a part one again. This time it's version 2. We're gonna start off with summarized data in a different format. So what I mean is, just pretend that X bar equals 31 and sum of X minus 31 bracket square equals 1947. Pretend that in version 2, this wasn't given. Instead, the following was given. Sum X equal 1860, sum of X minus 10 bracket square. Oh, did I not show you the number? Hold on a second. Oh. Wait a minute. Give me 1 second.
Oh, okay.
I forgot to copy down the number. Okay. What was that value again? Sum of X minus 10 bracket square. 28407. Oh, forgot to write it down. Over here. Sorry. Wow, this one's so important. Forgot. 28407. Okay. Then I want you to calculate the unbiased estimate of the population variance with this as a starting information in the version number 2. But before that, let's just focus on version number 1. So let's begin. Where is the okay? Oh, hold on. This one. Right, I'm using the wrong version. No wonder it looks weird. Yeah. Now, okay. So what we want to focus on is version 1 first. And actually, I already calculated it. I also took a screenshot of the MF26 formula here, right? The unbiased estimate of the population variance, as well as the information that is given in part 1. So how do we use this information? First thing you need to realize is that it looks very similar to what we need in the first version of the formula. Look carefully at this formula, you realize that in between the bracket is x minus x bar. Oh, and likewise over here, we got x minus 31, and just so happens that 31 is the same as the x bar. So that means we can just directly use the first version of the formula. The sample size was 60, so n is 60, then over 60 minus 159. Multiply it by sum of x minus x bar bracket square, which is the 1947. Then you divide by the n's sample size 60. You'll get 33 as an answer. Is that okay?
Yeah, okay.
Part 1, okay, right? So sometimes the version 1 is more efficient to use than version 2. Now I'll show you the other case. Now we try version 2. Version 2, we are given the following information instead. The summarized data. This time we are given sum of x equals to 1860 and sum of x minus 10 bracket square equals 28407. Notice this is sum of x, this is not x bar. Okay, so which formula do you think is more useful now? Version 1 or version 2?
2.
Version 2, or is it none of the above? There's a version 3 as well, right? Remember version 3? Just replace version. Sorry, I shouldn't keep on using version. I should say this is what's another word for version? Type 1, type 2, type 3. The type 3 formula is to replace the x with x minus a. Please remember this. Need to memorize. This is a free gift because using version 3 is actually more efficient in this question. Okay, it's actually a lot more efficient.
But there's no summation of x minus 10.
Don't have. Then that's when you have to calculate it on your own. Okay, make sense? This guy is easy to calculate from sum of x. Then you can just substitute in the rest. The alternative, if you wanted to use just the type 2 original format without the x minus a, you need to recover a sum of x squared. That's going to be very, very, very challenging. Not very, but very long-winded. Do you know what? Do you get it now? This is sum of x minus 10 bracket square. The version the type 2 of the formula requires some x square. Don't have a minus 10.
Yeah.
So we cannot directly substitute it. Okay, so the answer to this is to use type 3. Can? So we're gonna do that. We're gonna make sure our given summarized data can fit inside this formula here. Okay, so let's take a look. What do we need? We need summation of something. What's inside? Why is this something? It's the square of x minus a. Do we have the square of x minus a? Yes, we do, right over here. Square of x minus 10. In that case, a is equals to 10. We can deduce that from this by comparing these two terms. Is that okay? A equal to 10? Okay, good. So that means that the formula s square will just be 1 over 60 minus 1 multiplied by this fella here, which is the 28407. Subtract away a problem square over n 60. What's the problem here? You actually need sum of x minus a, and we have established a is 10. So this should be sum of x minus 10. So we don't have that. We only got sum of x. So what do we do? Calculate ourselves. What's sum of x minus 10? This is actually just short form for summation of xi minus 10, bracket, I goes from 1 to n. In this case, n is 60. So it's just a sequence and series kind of question, right? You just need to know how to read the stigma.
10 times 60.
Yes, correct. So we can split the summation up into 2 like this. And let me just write it out. Yes, you're correct. This sum of xi from 1 to 60. Actually, what is this value?
The 1860.
Exactly, it's 1860. Then you have to subtract away 10 times 60, exactly what you said. Yes, because here 10, even though it's not related to I at all, you can think of it as adding 10 60 times from 1 to 60. Oh, bonus question. If I take summation of, let's say, 5 from I equals to 3 to 6, what do you get? Is it 5 times 3? Okay, let's change the number to 4 and 7. What is it? 5 times
7 minus 4.
7 minus 4? Oh, forbid. How many numbers are there? I equal to 4, 5, 6, 7. If you take 7 minus 4, that's just 3, not enough.
Plus 1.
Plus 1. Must remember upper minus lower plus 1 in order to get the number of terms. Okay? Always have a plus 1. Yeah. If not, this is just the start of the part 1 of the sequence series question. Everything else error carry forward. Very dangerous, okay?
Okay.
You must get the number of terms correct. Always remember upper minus lower plus 1 equals to number of terms. Okay, so anyways, subtract away and then you finally get 1260, right? Right? 1260. Now type in the calculator. Let's check. Do we get back our 33? You can go and check on your own whether, if you don't believe me, you can go and check that it should be 33. But for this second formula, let me just check. Yeah, you get back 33. Okay. Is that all right?
Yeah, can.
And remember, okay, there is a type 3, version 3 of that formula that is hidden. You must use it. Okay. Now, what if we wanted to use version 2? Type 2. We need to recover which guy? Sum of x here. Do we have it already? Yes, we do. 1860. Then bracket the 1860 square. But do we have sum of x square?
No.
But we got sum of x minus 10 bracket square. Can we recover it directly?
No.
Not
Must
directly.
expand and...
Must expand it, right? So let me ask you a quick question. This one extra already. We already finished the question. We already finished version 2. Is the expansion of sum of x minus 10 bracket square the same as sum of x square minus way sum of 10 square?
No.
No, what's missing?
The
A minus b bracket square.
minus 20x.
Very good, 2 times a times b. Also minus 20x is missing. So you can tell that there are 3 terms. That's why it's going to be quite long-winded. Should I convince you that it works? You don't need this for A-levels. Do you want me to show you?
Don't need lah. Hopefully I won't do that. Yeah.
Yeah. Don't go and try and expand this, get 3 terms and go and split it up and try to recover sum x square. Worse still, you go and directly replace sum x square with this 28407. That's totally wrong. Okay? You're supposed to replace sum of x minus a bracket square, the hidden formula with 28407. Is that okay? Okay, now I did not use this guy. I used the third version. Okay, now that is version 2 completed. Let's look at part 2. Estimate the probability that the person, daily wage of these 60, okay, why did I say man? The daily wage of these 60 workers exceeds $32. Oh, that's a keyword. I'm so sorry. I finally remember. Mean. Or average daily wage of these 60 workers exceeds $32. Now we must remember this is a sampling topic. When you see this guys are almost certain that it's a sampling topic or hypothesis testing already. So I haven't go through hypothesis testing, but this is very related. When you see mean, you must think of x bar. Remember x bar? Sample mean?
Yeah.
Okay. I haven't explained to you, but let me just do it now. So for x bar, right? Okay, let's say we have x, it follows a question mark distribution. All right. We don't know what is the x bar, but it has a certain mean and a certain variance. Now this mean and variance, we usually use mu and sigma square when it's like a normal distribution. But that sometimes this question mark distribution, it doesn't have to be continuous, right? It could also be a binomial distribution. Then you will use E of x. or we'll use like var of x notation, right? Also the same, right? They all mean they're just funny notations for the same thing. Okay? Question mark. We don't know. Now, even though we don't know its distribution, as long as we know its mean, we know its variance, we can make a deduction. We can deduce that x bar, if we define it to be x1 plus x2 plus ... until x sample size n, divide by sample size, that's a mean, right? Average. Add everything together, divide by number of numbers.
Yeah.
If we define this to be this guy, we can actually deduce some things about it. Actually, let me just confirm first. We don't know its distribution. Okay. Oh wait, no. Sorry, I started it wrongly. I should start off with normal distribution. Flows better. Okay, let's assume. Okay, sorry, can I try again?
Sure.
Okay, restart. Okay, let's say that we start with a normal distribution, something that's we are all familiar with. If we want to find out x bar, which is by definition x1 plus x2 all the way to xn, if you're interested in this guy, how do we know when we are interested in this x bar? It's when the question says something like the mean or the average daily wage or something like that. Okay, well, keyword mean or average.
Okay.
Then we have to look at x bar. In this case, because x start off with a normal distribution, we know that this guy will also follow a normal distribution. The mean is still mu, coincidentally, but the variance is a bit funny. It's sigma square divided by just n. Do you have a square here?
No.
Square. Okay, very good. Now let me try to prove it to you. This mu here is just expectation of x bar. I'm trying to show that expectation of x bar will be equal to the same, this guy here, which is the expectation of x. Oh, we're gonna prove that they are the same. This is you want. This is not a proof, sorry. Maybe I should put proof underneath it. Yeah. That's what we want. Now the proof. So expectation of x bar, we can replace the x bar with what? Whatever we have defined it to be. Now, when we take expectation of when there's this 1 over n multiplied to it, we can actually factor our constant 1 over n. Then we're left with summation of x1 to xn. Expectation of the summation from x1 to xn. Okay. Then by linearity of expectation, right? Expectation is what? Expectation of any random variable x is just summation of x. I goes from 1 to n, divide by n. So because summation is what we call linear, meaning that if you got like sum of x plus y, it's really just the sum of x plus sum of y. So we can extend this idea to n different terms and split it up into expectation x1 plus expectation x2 plus expectation x3 ... until eventually expectation of xn. Bracket all multiplied by 1 over n. But here we're gonna assume that all of the xi's are IID. What does that mean? Independent and identically distributed. In particular, identical distribution. Identical distribution just means that if x, you start off with x, you can split up into x1, put an index I. So x1, x2, x3. If it start off with a normal, it will be normal for every single distribution. And identical here means that not just the normal distribution is the same, but the mean and the sigma square is also the same. In particular, the mean is the same for every single one of these guys. So it means that we can substitute each of these guys with the same value, let's just say E of x1. Because x1, x2, x3, they're all identical. So we can just have the same expectation. Sorry, I don't need 2 anymore. I change it into 1. The expectation is the same. Expectation is just some number. A number plus a number plus a number, and they're all the same numbers. So it just becomes n times of expectation x1. Is that okay? With a 1 over n in front?
Yeah, can.
Then n will cancel away. You're left with expectation of x1. Of course, it doesn't have to be 1. I could have put 2, 2, 2, 2, or 3, 3, 3. It doesn't matter. because at the end of the day, expectation of x1, or if I chose 2, 2, 2 here, it will become a 2 at the end of the day, expectation x2. It doesn't really matter because at the end of the day, it will just be equal to mu, which is exactly expectation of x. Okay, so we have proven it. E of x bar is expectation of x. That's why it stays the same. But what about the variance? Why is there a divide by n? How come sigma square becomes sigma square over n? Where's the n square? Let me show you. So our goal here is to show that variance of x, which is sigma square, variance of x bar is sigma square divided by n. Okay? Can?
Okay.
Okay, now let's proceed to prove it. So what I want to do, I'll start off with the conclusion we want. Actually, this should be implies that. So variance x bar, what is it? Again, you substitute x bar with 1 over n times x1 plus x2 all the way to xn. Okay? Then what happens when you have a constant here? You can factor out from the variance. So can you just factor out like that? What's missing? When you factor out a constant, if this is just an a.
Square.
I'm
A
making a
square.
square, right? So of course the a is 1 over n in this case, so 1 over n bracket square. Okay? So it's 1 over n square times the variance of all this. Okay, I'll just copy and paste. But wait, what is the variance of a sum? Here we are assuming that xi's, x1, x2, x3, x4, all the way to xn are IID, in particular, independent and identically distributed, in particular, this part here, independent. When it's independent, our variance can be split up into a sum of each of those variances. Okay? If it isn't, then there's another formula that is available in university that you don't need to know about. Called covariance, but you don't need to know it. Okay? Yeah, I'm just gonna jump to that. So independent, that's why you can split it up into a sum of each variance. All right. Then what else do we know? We know that it is identical. Identical. So that means that identical, IIDENTICAL, sorry, handwriting. Identical distribution means that the variance of this x1, x2, xn, they're all the same. And let's look at what's the variance of x1, x2, and xn. Basically, I'm just taking this guy, put an index I, so it's basically sigma square for all the xi's. Is that okay? Can then eventually it's gonna become sigma square over n. So now we're gonna substitute in all these fellows with sigma square, sigma square, sigma square everywhere. How many of them are there? Index 1, index 2, all the way to index n. So how many?
N
Upper minus lower plus 1.
plus 1.
Which is just n lah. Okay, so n times of sigma square. Is that okay?
Yeah.
Then there's a 1 over n square in front. What happens? Sigma square, n and n square, one copy of n disappears. You're left with sigma square over
N.
got square or not at the bottom?
No.
Don't have. Convinced now?
Yeah.
Yes. Then from now onwards, just memorize. I'm sorry, but faster way. Yeah, you need to go and memorize already. No n square. Is that clear? Can
Yeah.
No square here. Okay, good. Now that is when it's a normal distribution. How about let's go back to what I was talking about at the beginning. Let's say that we don't know its distribution. Okay, we didn't know its distribution. It could be anything. It could even be binomial distribution, which is what is one of the questions. I think question 5 you couldn't do. Or normal distribution or whatever, doesn't matter. X bar, we won't know its distribution. However, we can make an assumption. If n is more than or equals to 30, okay, it's in the syllabus. Wait. Let me find your syllabus. Hold on a second. Syllabus. Where is the syllabus? Where did it go? Nope, not this one. Oh, wait, it is. Yeah. Okay. It's not this one. Yeah. There we go. Okay, and then I scroll down. Here, use of central limit theorem, okay, to treat a sample mean, the X bar that I was talking about, to be to have normal distribution when the sample size, the n, is sufficiently large. Example, n more than equals to 30. Okay. In the syllabus, I never make things up. It's in the syllabus. So, oh, wrong file, wrong page. Wait. Yeah, so here, what happens when n is more than or equals to 30? Or n is large? Sometimes the question won't specify the value of n. We're gonna assume that it is large. Okay, then we can quote central limit theorem. We'll say that X bar approaches in distribution, it approaches a normal distribution with mean being mu, variance being sigma square over n. So you realize that it's exactly the same as the previous one. This is called central limit theorem. The X bar will approach the normal distribution, will converge in its distribution towards a normal distribution. What is converge? You don't need to know. You just need to know that we can assume that X bar will follow normal distribution, mean mu, variance sigma square over n, no square on the n. Okay, when little n, the sample size is large, more than or equals to 30. Okay.
Okay.
Can yeah. So with that, we can begin going through the tutorial. Okay, let's go to tutorial now. I'll send you the file later. Yeah. Where is is it this guy? Wrong file. Yes. Okay. Here. Okay, I won't go through the first few questions. I'll just go straight to one of the ones that I saw there's a problem. Here. Wow, cannot. No. X bar plus Y bar. Cannot. Let's read the question for the part 2. Find the probability that the average of, so it means it's something bar, question mark bar, of the 50 observations of X and 30 observations of Y. This requires you to define a new random variable T for total. This will be equals to x1 plus x2 all the way to x50 plus the y1 plus y2 all the way to y30. Then the whole thing, because there's 50 plus 30, all together becomes divide by 80. Is that okay?
Yeah, can.
This is correct. Is this okay? This will follow the distribution that you've written over here. It's okay on the right hand side, but the left hand side doesn't make sense because if you write down the left hand side, that is not equal to the right hand side. Do you know why? I mean, I'm sorry. It is this guy. It doesn't match up with the right hand side distribution. Mean variance. Do you know why?
Because it's not the 50 observations. Like it's not the sample.
No, X bar plus Y bar, it wouldn't end up with a divide by 80. It will end up with something a little bit odd. Let's see what is X bar and Y bar actually. X bar plus Y bar is literally, what's X bar? x1 plus x2 all the way to xn. In this case, n is what? N is how many data? Oh, 50. Divide by 50. Okay? Divide by 50, not 80. And then what is y bar? It's literally y1 plus y2 plus y, what's the last one? Y30 divided by its size, 30. That is not what the question is asking about. That is different from what they're asking of. They're saying average of this whole chunk inside the square bracket. Here, what you found is average of the 50 observations and average of the 30 observations added together. That's different from what they're asking.
Yeah, I just thought I could shortcut the writing. I know it looks a bit funny.
Yeah, if you actually wrote this off, then the normal distribution is under the normal distribution, mean and variance will be different already. This guy, which is what you wrote, the normal distribution would be what? You just take the expectation of x bar plus expectation of y bar, which means you already calculated here 24 as well as 15. Actually, y bar. Hold on. Well, I noticed another mistake. Here, they said that y, not y bar, is normally distributed with standard deviation 1.5. Here, you wrote down y bar. So you're missing a divide by n dot d here. Right?
Yeah.
You got lucky with the calculation here. But okay, the normal distribution, if you are actually if you wrote down x bar and y bar and I read it literally, it would be n of 24 plus 24. This is expectation of x bar plus y bar, which is equals to expectation x bar plus expectation of y bar, which is 24 plus 24. Then comma, the variance will be variance of x bar plus y bar. We're going to assume that x and y are independent, so x bar and y bar, which are made up of xi's and yi's, are also independent. So we can split it up as a sum, like that. Okay. Then from there, is this accurate? I hope it's accurate. From there, we can factor out a 1 over n square. And then we take the variance of the sum from x1 up to xn. In this case, n is what? 50. So it's 50 square, then 50. Plus variance of y bar, we do the same thing. So it becomes 1 over 30 square times variance of y1 plus y2 all the way to y30. Then from there, because of independence, this one you can split up further into variance x1 plus variance x1 plus variance x2 plus dot 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 plus variance x50. And each of them have a variance value which is 2 square. 2 square. So that means there's 50 of them. So this is 50 times 2 square. Then that guy will be what? 30 times, let's see, what is it? 1.5 square. Okay. This will be simplified down to 50 times 2 square over 50 square. 50 cancel away. You're left with 2 square over 50 plus this one, 1 over 30 square times 30 times 1.5 square. 30 will cancel away. You're left with a 1.5 square over 30. That is the variance of x bar plus y bar. Very different from what you have here. Okay. Yeah. So you should be defining a new random variable like this. Okay. Yeah, but otherwise your working is fine. Okay. Wrong random variable written, but correct calculation. Okay, you got the right idea. Question 6. Okay, yeah, this is fine. Okay, just distribution. Yeah, just CDF. This one binomial, you calculate the mean. Okay, can. Okay, nothing to talk about. Question 8. Yeah, okay, so for question 8, you need to treat this as a CLT question. Okay, CLT question. We're gonna assume that the sample size n here is large. Okay, large, also more than 30.
But
you have to assume that.
Can because they
Because they
say
mentioned
large
large.
number. Okay.
Yes. Okay, so what does that mean? Let's just let x be the random variable that represents the binomial distribution. So like I said previously, you can have question mark distribution, if you recall, right? Where did I write it? You can have question mark distribution now. In this case, it's binomial. As long as n is large, we can use CLT and conclude that not x, but rather x bar follows this fella here. Oh, sorry, I should just circle this one. X bar follows this distribution here. Mu being the mean, sigma square being the variance of the original x. We may not know its distribution, but we can calculate its mean and variance. Or rather, not don't know. I mean, this distribution can be anything. In our question, it's binomial. Oh,
yeah.
Okay. So let's just apply it. So from here, we can calculate the. Oh, sorry. Is it right? Yeah, we can calculate the expectation of x, which is just NP. So 20 times 0.2. What's that? It's just 4, right? Is it? Yeah. Then how about variance of x? This is like your mu, This is like your sigma square. Then what is your variance of x? It will be NPQ. Okay, maybe I write the formula. This is NP. This is NPQ, where Q is 1 minus P. So it's 20 times 0.2 times 1 minus 0.2. This is some number, 4 times 0.8. That's 3.2. Then, so what we have now, we have this x that follows binomial distribution. Here is n, here is p. So you cannot put in your mu and sigma square here, but we can, I guess, write it below. Mu is 4, sigma square, the variance equals to 3.2. Okay, then we can say since n is large, by CLT, we know that x bar, okay, make sure you got a bar, which is defined to be 1 over, in this case, n is large. We don't know what is n, just, okay, this part is extra. You don't need to write down the definition of x bar, but just in case you forget, 1 over n times x1 plus x2 all the way to xn. Then you divide by n times 1 over n. X bar will now follow normal distribution, with mean being whatever we calculated, the mu, which is 4, comma, what would it be? What's the variance? Can you tell me?
The 3.2 over
3.2 over
the
sigma square over
like n.
n, just n. Oh, sample size n. Typically, they will tell you the sample size, but this question is tricky. They did not tell you. Like just now, our previous question, we got sample size 60. Now, if it was 60, you put a 60 here, but we don't have that. So just put an n. Okay. The reason why it's n is because you need to calculate n. They gave you a condition. Approximately 90% of the sample means are less than 4.354. 90% is just a probability, so 0.9. So somewhere on the right hand side. Then P of something on the left hand side is approximately, so equals 0.9. So something equals 0.9. What is equals 0.9? Probability of something. Probability of what? Sample means, right? Sample means, which is your x bar, are less than. So in other words, x bar is less than 4.354. Okay?
Yeah.
But this one, can you use the normal CDF? Look carefully at your mean and variance. What's the problem? Cannot. Why? Because
the variance is like unknown.
So that's when we need to use GC, the y equals function. Okay. If not, you can standardize this distribution and then you do it manually. Do you want to see the manual way?
Can.
Okay. Manual way. It's all in the solution actually. So basically for the manual way, once you don't know the one of the variances, you cannot use the normal CDF. You have to do standardization so that you can convert this into Z, which follows N01. And what's the procedure? You need to, for Z, it's always equal to X minus what?
Mu over sigma.
Now take note that this X can be any distribution. In this case, it's actually X bar. Okay. It can be a D, D for distribution, anything. But you just minus its mu, divide by its sigma. So here, that's exactly what we're going to do. X bar, we're going to minus away its mu, which is 4, divide by its sigma, which is square root of 3.2 over n. Okay, but that's just equal to, and as if we did that on the left-hand side of the inequality, we can do that on the right-hand side as well. So 4.354 minus away 4, divide by the square root of 3.2 divided by n, bracket p. But of course, this fella here is really just z. So actually, we didn't have to write it. We could have just written p of z less than 4.354 minus 4 over square root of 3.2, sorry, over n equals 0.9. Okay? Then from here, because z will now confirm follow n01 distribution, we can use the inverse norm. Use inverse norms, sorry, not normal CDF, in order to solve for this expression here. Okay, it's in the correct format already. That's it. So if you use inverse norm, what do you get? Do I need to show you?
Don't need.
Don't need, okay, so let me just grab my calculator. Okay, I need to calculate this. So second distribution, take the inverse norm of area 0.9. So you end up with 1.28. 1.5. Okay, then from there you can solve for n. Is that okay? I'll leave that to you.
Yeah, can.
But you need to round off to 42. I think that's the answer. Yeah. Then alternatively, you can use the GC. Do you need me to show you the GC method?
Don't need.
Don't need, just how would you do it? You calculate the CDF, but when you're keying in the standard deviation, you take the square root of 3.2 over x. Or use the variable x, the xt theta n below the link button. You know that button, right? Variable button on the GC. Okay, don't need to show.
Yeah.
Okay, can. Next, let me shrink this down so it's not blocked. Okay, moving on. Okay. Oh, right, I can put it here. Okay, next. I haven't read this. Let me see. For normal distribution, mean standard deviation. Okay, yeah, if you mark it correct, then I don't check. Is that okay?
Yeah, can.
Okay. Tick. Part B, circle. Okay, let's read the question. Reading age of children about to start a secondary school is a measure of how good they are at reading and understanding the text. A child's reading age measured in years is denoted by the random variable x. Distribution given by the following. Normal distribution, mean, mu, variance, sigma square. Reading age of a random sample of 20 children were measured and the data is summarized by the following. Sum x square. Calculate unbiased estimate of mu and sigma square, giving your answer to 2 decimal place. Okay, part A is fine. Part B, in order to obtain a more accurate size of mu, it is proposed that a larger sample be taken. Estimate the sample size needed so that we can be 95% certain that the sample mean reading age. Sample mean so some x bar let the larger sample be y. That's a bit odd. Sample is referring to sample size. Larger sample means larger sample size. So it's an n. You want the n to be bigger, not the random variable. Do you get what I mean? Or did you mean to say let the random variable with a larger sample size be y?
Yeah.
I have to be careful with the phrasing. Larger sample sized the adjective random variable. Larger sample sized random variable by.
I must have the random variable.
Yeah, actually you don't need a random variable. You just need to define the n to be the new, like a new letter n to be the new size. Because our emphasis is on the sample size. Okay. Can. Yeah, and we need a x bar. Okay. So actually what we need It's not a y. We need an x bar, okay? Because we are talking about sample mean reading age. Okay, x is what? X is reading age. But here they mentioned sample mean reading age. Can you see the difference? Child's reading age is x. Sample mean reading age. Now that's what part B is talking about. In the preamble, we talk about x being the child's reading age. In part B, we talk about sample mean of the reading age. So of course, you must know a CLT question already, huh? X bar. We're focusing on X bar. Is that clear?
Yeah.
Okay, so then you just use formula law. Okay, let's say then they also mentioned the keyword already, larger sample. So since okay, you know what, I'll just say let n be the larger sample size. We're gonna assume n is large. Sorry, the handwriting. I hope you can read. Assume n is large, then by CLT, we conclude that x bar follows normal, mean stays the same as mu, but the variance becomes sigma squared over n. Okay? Can?
So I'm just missing the size.
Say again?
I'm like just missing the size in the definition.
Yes, I guess, but not just that. You also don't want to look at y. You want to use x bar so that it's obvious to everybody that you're looking at the sample mean. Okay.
Oh, so
I think you're calculating sample mean.
if I use y, it will be wrong.
It's not wrong, but it's confusing.
Okay.
Yeah. Okay. Can then in this case you want to be 95% certain that the sample mean reading age differ from the true mean reading age by less than 6 months. The true mean. So actually, what am I looking for? X bar minus away something to be less than 6 months. You want this probability to be 0.95. What is the true mean reading age? What is the true mean reading age?
The mu.
Yep, mu. Okay. Then from there, what are they asking? Estimate the sample size needed. Interesting question. So in this case, we don't know the value of mu, but yet we're trying to calculate the value of n. Oh. Okay. How do you get a 2.25 here? How come got 2.25?
The
Huh?
question.
I got 2.25.
Assume that it is known from previous studies that the variance is 2.25.
Oh, sorry, I didn't read the question carefully. Okay. Right. Oh, we can assume that sigma square is 2.25. Okay. All right. I didn't read that carefully. Sorry. So I can replace the sigma square here with 2.25, is it? And that's why you did, huh? Actually, in that case, if you just wrote down 2.25 without dividing by n, then it's totally wrong already. Because you weren't answering the question sample mean reading age. You didn't try to use this formula at all. So yeah, no, wrong. It's not 2.25, it's 2.25 over n. Okay? Okay.
Yeah.
I also realized I made another mistake here. 6 is months. That's why they underlined it for us, months. But x is measured in what? X is measured in years. So 6 months is actually half a year. So that's why it's 0.5. I think that's what you did also.
Yeah.
Yeah, so I made a mistake. Change 0.5. Okay, good. Then from there, we need to solve this. How? I think we have to make use of the symmetry. So let's try and open up this modulus. What do we get? We'll end up with negative 0.5 less than x bar minus mu less than positive 0.5, right?
Yeah.
Now, I think it would be smart if we try to standardize it. Also, x bar, if we try to standardize, we have to subtract away its mu, then divide by its what do you call it, standard deviation, which is square root of this guy. Also, that's what we're gonna do now. We're gonna divide by square root of its variance throughout the inequality. So what happens when you do that is the middle guy becomes a z. So we are left with p of the left half less than z less than the positive version of the left half. Also, I'll just copy and paste it, but remove the minus. Equals 0.95. Can?
Can.
Standardization. Okay, now this is a normal, this is z, where z follows what? N 0, 1. How does the graph look? Symmetrical about?
About the mu, the zero.
Mu equals 0. Very good. So this is 0. Then what do we want? We want it to be in between negative 0.5 over square root something or positive 0.5 over square root something. By definition, the square root is always a positive value. So that means that this fraction is negative, this fraction is positive. And I hope you can tell that they are symmetrical. They have the same absolute value, right? One is negative, one is positive. So that just means where are they? This value is the negative 0.5 over square root 2.25 over n. And that other value will be the positive version. Does it make sense?
Yeah.
Can, one negative, one positive. The other side is the positive version. Then what do we want? We actually want to find the probability that's in between negative 0.5 over whatever to positive 0.5 over whatever. That just means we want the area under the curve in between those two boundaries, which is this guy. And we need this to be what? 0.95. Right?
Yeah.
Then from there, we can just inverse norm. But let's just be a bit more careful. We need the area here to be 0.95. And we know it's symmetrical. So that means that these two tails, the left tail here and a right tail there, they should also have the same area, right?
Yeah.
So what will those areas be? Must be 0.05 over 2, which is 0.025. Is that okay?
Yeah.
Okay, then that means that this total area here, the left tail area, must be how much? 0.025 plus 0.95, which is 0.975. Right? So let's redraw to make it a bit neater. What I mean is, from here onwards, this is this area here all the way from the left until the positive 0.5. Let me copy and paste it. That black color area that I just shaded here is 0.975. Okay, 0.975. Maybe I'll change it to red. Then how do we find the value of this x, or this what we call the quantile value?
Is the 1 minus 0.975.
Wrong. No. I'm not talking about area anymore. 1 minus this will give you the right tail area. No, I'm talking about this guy here. How do you find this value? When you have area, a left tail area, up to a upper limit, like a boundary, a right boundary. How do you find the right boundary's value? You use your GC and you use what function?
The inverse norm.
Very good. Okay, remember, inverse norm helps you to find the area. Sorry, it helps you to find this, what we call the quantile value. Using the inverse norm function. provided that you feed into the inverse norm function the following. You must feed in the mu, you must feed in the sigma, and you must feed in the area. The area being the left tail area. What do I mean by left tail area? What I mean is this area I'm about to highlight in what color? Green color. Can see or not? This
Can.
entire area green is what I refer to as the left tail area. Okay, which is why I tried to calculate this 0.025, this 0.95, add them together to give me my total 0.975. Then now finally use inverse norm function. Then you will be able to obtain 0.5 over square root 2.25 over n to be equal to what is it? Yeah, so you don't inverse norm with the area 0.95, by the way. Do not key in 0.95, that's not correct. You should be keying in 0.975 with the left tail area. So let's see what value we get. Do you want me to demonstrate to you?
Can.
Okay, can. Hold on a second. I need to set it up. Hold on. Is it loading? Is it showing?
No.
The GC. No. Okay, wait. I need to share screen.
Yeah, can.
Oh no. Oh no. Oh no. Wait. Let me change screen. How do I remove this? Give me a moment to set it up. Yeah. Right. This is share screen. Can see?
Can.
Okay, good. Okay, so how to get that? Oh, can I detach LCD? Okay, I don't know if it's useful or not. Let's put it here. Okay, so what I need inverse norm, right? So I'll just clear the screen first. So inverse norm, second, then you press the distribution button. You scroll down to inverse norm, and then the area you must key in 0.9. What is it again? Is it 0.95 or is it 0.975?
0.975.
0.975 must be the entire left tail area. 0.95 is the middle area. Doesn't include the left half, which is bad. Okay, so we key in 0.975. Mu is 0, sigma standard deviation is 1 because it's a square root of the variance 1. It's a standard normal distribution. Enter, and you finally get this 1.9599. Okay, good. Then from there you can solve for n. All right.
Yeah.
Can good. Anything? Yeah. Then from there you solve for n. I think that's all. Okay. Let me just check the answer. Yeah. Okay. It's yes. That's all you need to do. Then you solve for n. You get a 35. Okay. Okay.
Yeah. Can.
All right. Let's move on. Hey, let me just set up the screen first. Okay, which question next? I need to resume share. Okay, can then this is correct, nothing to say. This one wrong. Okay. This one is exploration already. Coded form. Yeah, you don't need to worry too much about this. Extra already.
Oh.
Yeah, exploration, explore. I think you can explore in your own time if you have time. Do you have time? I'm
So
not gonna.
they won't really test lah.
Yes.
Okay.
No. Okay.
Mm.
Can I? Can
Yeah.
I? I'm gonna skip that. Okay. Can. What else? Is this notation correct?
Yeah, it looks funny, but I don't know.
Let me read first. Farmer takes random sample, 10 melons grown in his X kg, blah blah blah. Population mean are denoted mean and variance, mu and sigma square. Calculate unbiased estimate. Okay, using the actual data. GC one variable stats. Yes, you can do that. I don't usually use it. 6 equal to that, then S square equal to that. Okay. Then another random sample of 40 melons is weight, and the results are as follows. Combining the two samples into a single sample, find the unbiased estimates of mu and sigma square. Okay, so let me see. Okay, just a note. Oh, please don't make it curvy. Please make it like straight. Sum of x plus y. I guess it's okay. It's okay. Can.
Okay.
But you need to make sure that you define what's y lor. Oh.
Okay.
Like in this case, other 40 runs be denoted by y. Okay. Actually, you shouldn't do that. You know why? Because the other sample of 40 melons, then they give you the summarized data sum of x already. So 40 melons is x. Then here you go and change it to y. You're trying to go against the question. All right, so your y should be this guy. Should be the first 10 melons. No?
But the first 10 melons was already X.
It's also x.
Then how?
Can just define a brand new random variable z lor. Okay, don't use c. How about d? Just let d be the random variable for mass of all 50 melons. Then the sum of d will be equal to sum. Then in that case, you just give up on the notation. Just sub in the numbers already. Okay. 5.738, the sum from the 40 melons, and then the sum from the 10 melons, which you calculated. I don't know what the value is. Sum all this. Okay. I think that works. Just let d be the random variable for the mass of all 50 melons. Yeah. Hmm. 85. How did you get that? Okay. I think it would be better if you don't use that notation x plus y bracket square. Just let there be a brand new random variable, just a single letter. Because the moment you try to introduce the x plus y bracket square, you're gonna introduce like illegal notation. Why illegal? Let me explain. This part here, what you meant to write was a summation, right? Sum of x plus y bracket square, you can expand this square, then you end up with x squared plus y squared plus 2xy. That's very problematic because 2xy, you need to go and take the summation, which is a bit difficult or impossible to calculate here. What we are doing is not this guy. What we are doing is actually sum of x squared from the sum of, let's say we use letter d, right? Then small letter d, sum of d squared. Then you can split that up into sum of x squared plus sum of y squared. If that makes sense. Okay, it shouldn't define a y. So basically, this d represents the 50 melons. So d I goes from 1 to 50. Then maybe from D1 to D40 will be the 40 melons, and then D41 until D50 are those other 10 melons. So it's just the sum. Okay, this is correct. This is fine. But the notation wise, don't put bracket square. No, in this case, we are not doing x plus y bracket square. We're literally doing, I think, something similar to x squared plus y squared. Or more simply, just introduce a new letter, capital D for distribution, then little d for its for the value. Then di bracket square. I don't need bracket, just d.
So I say let D be the sum of the two samples.
No, be the random variable for mass of all 50. I guess so. No.
Oh.
Should be not 40, should be of 1. Mass of 1 melon among all 50 melons. Actually, right, if you look at the solution, they didn't actually try to define any random variable. They just go and recycle the x.
But isn't that wrong?
Is it wrong? A little bit. But I guess from the context it's clear, but it is clear that you have a first sample and second sample because of the way they presented it. First sample, second sample, so it's clear that these are not related. They're just using the x as just a dummy variable that has not much meaning.
Oh, okay.
Can just put first sample and second sample. I think it's clear enough.
Can.
Yes. Okay. Can next let's look. What else we have? From past trends, NHB of a certain country reported mean cholesterol level for the country's population. An employee investigate cholesterol level of people, whether it changed or not. She collected random sample of 30, sample mean x bar, sample variance 281.5. Find the unbiased estimate of population variance. State the approximate distribution of the sample mean. Must be normal, I guess. Right? Sample mean is just talking about x bar. And then they use the magic number, random sample size of 30. So that's large. Then we can quote what theorem?
The central limit theorem.
Central limit theorem. We conclude that x bar must follow a. So when you see sample mean, then it means it's x bar follows
a normal distribution.
Normal distribution. That's all. Right? Is there anything else to it?
Oh, so that's what I was supposed to say.
Yeah.
Oh, okay.
Yes. Just it's basically this is a standard line. This is a very, very, very standard line that you have to say. This is a very efficient way to say it. N is large, x bar follows n, then give the mu, give the variance sigma square over n, no n square. Just divide by n. Then approximately by CLT. Approximately by CLT. Oh, this is a standard phrase. Very accurate and also very short. Short and concise. Very nice. Accurate as well. Okay, then how about part 2? What? Part 2, is it okay? Why? What do you mean why?
Like why must I round off to the nearest whole number? Because I see the answer they give is 193, so I put 193 also.
Oh, okay. I think it's just 193. Let me read first.
Cholesterol level, which is not really.
Yeah, it's continuous. It doesn't have to be a whole number.
Okay.
Or is it 3SF? Let's see the answer, Oh, let me read first what I see. Another random sample of 30 is chosen, given that the probability of the sample mean being the x bar being less than C milligrams per deciliter, or deciliter, is not more than 0.05. Find the largest value of C. Okay, so it's less than the x bar of 193. Yeah, it doesn't make sense, this question. Part C doesn't have to be a whole number. There's no reason.
Oh,
Yeah, it doesn't
okay.
have to be a whole number. No, okay, just ignore the question. Largest value doesn't make sense because we just need to know that after you inverse norm, you get 193.875. Right? So it means that the graph here is 193.875. Less than this value, this area is less than or equal to 0.05. Okay, maybe my vertical line should be to the left of the maximum point, less than 0.5. This area here, the left tail area, must be less than or equal to 0.05. Also, that means that your C value has to be smaller so that the area will be smaller than or equal to the 0.05. But what is smaller than 193.875 and the largest possible value? It could be 193.874 or 193.873, 872, 871, 870. Many possibilities. Then you want largest value. You can pick what? 8749, 193.8749, or 193.87499, or 4999, 4999999. Is there a largest value? I don't think so.
Ooh.
Okay, it doesn't make sense, this question. Ignore.
Okay.
Sorry, please ignore. Okay, wasted your time. Okay, moving on. Supplementary, you did it. Sorry, you did it as well?
Yeah.
Okay, let's take a look. The mass in grams of randomly chosen jar of tasty brand jam is a random variable following this guy. For yummy brand, it's following this guy. Find probability that the masses of two randomly selected jars of tasty brand jam. So it's not two times, it's two different jars. So we have to put tasty's random variable. What letter do you use? You use X. So X1 and X2. Okay. Did you do that? Very good. X1 minus X2. Then modulus more than 10. Differ by means modulus. Okay, can. Then just split it up. What do you do? Hold on a second. Wait, how come here something funny happened? Negative multiply over should get negative 10, but here is still a positive.
Um,
Should have a negative? How did you get the correct answer? What?
I times A.
Actually, I am a bit confused by writing. Let me think a bit. So whenever you got modulus of the difference of two random variables like this, modulus more than 10, standard formula is more than 10 means the difference is less than negative 10 or more than positive 10. So just copy and paste the insides, less than negative 10, or copy and paste the insides, more than positive 10. And then of course this is OR, but in terms of probability, you will change the OR to a plus. Oops, sorry. P of the first inequality plus P of the second inequality. Did you get that? X1 minus X2 more than 10, that's fine. X1 minus X2 less than negative 10. This part is okay, but this part, not okay. It shouldn't be, what? Wait. Hold on. This is not correct. This is wrong direction. No. If you want to write it as plus minus, which is not what I usually teach you, your inequality must keep it in the same direction. If you want to change the inequality direction, then you must strictly follow this rule. When you got whatever is inside, you copy and paste it. When you have a positive number here, you split it up into a negative, less than negative, or more than positive. Think of it like this. Modulus means the modulus, and then you have a minus there, means the distance between these two variables on the number line. Then you want their distance to be more than 10. So what does it mean? It means that their difference must be less than negative 10 or more than positive 10. This will guarantee that you have a difference having a distance that's more than 10. Does it make sense? Standard formula. Must remember, modulus x minus a more than some b means that you have negative b. Sorry. Copy and paste the insides x minus a. Don't go and put plus minus. No, don't do that. Just follow this way. X minus a less than negative b or x minus a more than positive b. Okay, the plus and minus on the constant right hand side. Okay, then less than negative, more than positive. Can?
So that one is not correct, because I've.
Yes, this is wrong. Should be if you want to keep the negative here, it should be a more than.
Oh.
If you want to keep the less than symbol here, this negative shouldn't be here. It should be a negative.
Because I saw from like a guidebook.
What guidebook? Oh my goodness.
From like a tuition center.
Okay, try to be careful. Don't follow wrongly. Yeah, maybe you read it wrongly, or maybe the book is wrong. I'm not sure. Okay.
I also don't know because the book wrote like that.
That's very weird. Okay, try not to do that. Let's say just a quick example. If you got probability of modulus x minus 3 less than, less than 0.7 being equals to 0.4. How would you expand this? Let's say this is a random variable x. Sorry. X follow, I don't know, n01.
The negative 0.7.
Sorry, p first, p open bracket.
Then negative 0.7 is less than x minus 3.
Oh my goodness. Wrong already. No. Wait. Hold on. Let me think a bit. Oh, you're correct. I'm wrong. Getting tired. Okay, yes, continue. Then less than?
Less than 0.7.
Okay. It equals 0.4. Okay, you can figure that out on your own. Is there even a solution? I'm not sure if that's actually a solution. Okay. Not too clear. Maybe I shouldn't be so precise. I shouldn't put a 0.4. Just put it as an unknown. Call it k. Solve for k. Yeah. So let's see. What about, let's say you have modulus of x minus, x plus 2 more than 7. This is equivalent to what? Mic test. Can you hear me?
Can.
Okay. X plus 2, modulus x plus 2 more than 7. What is this equivalent to?
Or the p bracket.
Let's say we don't look at probability, just focus on an inequality on its own.
Oh, x plus 2 is more than plus minus 7.
Let's not talk about random variables, so just little x. X plus 2 more than what again?
Plus minus 7.
No, wrong. No. Cannot do that. No. I write again. X minus a modulus more than b is equivalent to copy and paste the x minus a 2 times, or in between, less than negative b for the left side, more than positive b on the right side. Can you do that? I mean, maybe a and b's are confusing. I change it to actual numbers. Would that help?
Oh, so to solve inequality is not the plus minus.
No. Yeah. Yes. You do not plus minus. That's illegal notation. No. Doesn't even make sense. If it's more than -7 and more than +7 at the same time, that means that you can only be x more than +7. Not really accurate, huh? And anyways, if it's an or more than -7, that's not correct. It should be less than -7. Okay, so you have to write it in two separate branches. Okay, you must remember when it's more than, you must split into two branches. If it's less than, what you did just now was correct. Chain inequality is okay. Just one single chain of inequalities is okay. So can you try x plus 2 more than 7 modulus?
The x plus 2 less than -7, or
And
x
or?
plus 2 more
And
than,
or
more than 7.
Very good. Okay, then from there you continue. Okay, can inequalities. Yeah, go and practice on your own. No, just come up with some inequalities and then just make it more than, less than, and try and figure out.
But if I times negative to that,
Which part?
that like formula, it still doesn't work.
Yes, this totally wrong. No. If you think about it, what should it be? Let's expand it. Okay, right? I already expanded it over here for you. P of this guy will become P of this guy. Plus, I change the or to a plus sign once I bring in the P. Look carefully. This fella here versus this fella here. Are they the same? What happens if you times -1 to this guy? Negative become positive. 10 becomes negative. 10. Then the sign, you need to flip it around. So positive x1 minus x2 is more than -10. More than -10. That contradicts against my answer.
Oh.
You are wrong.
Oh.
Okay. Yeah, I don't know how you got the right answer.
Because I thought the probability is the same, so I
Just
just
2
take,
times.
yeah.
And in this case, let me see. What is x1 plus x2? x1 minus x2. Because it's n0, 32. Yes, you got lucky because it is the same. Because it's the mean is 0, so it's symmetrical about the origin. In this case, x1 minus x2 less than -10 and more than +10 means what? The actual calculation. It would be a graph like this. This is the PDF. This guy here is x equal to 0. Why 0? Because you calculated here already. The mean is 0, right?
Yeah.
Actually, now I didn't check this. Let me check first. What is the variance? How come you have a 32 there? 16 minus 6. Okay, yeah, correct. Okay, good. So x equal to 0 is the line of symmetry there. Then we have x1 minus x2 less than -10, more than +10. So, sorry, that means that you should have a -10 here, +10 there. You want the area to the left and the area to the right. Okay, and they are, because of symmetry, the same. That's why you managed to get lucky, and even though your inequality was wrong, you managed to get the right answer. Because your right hand side was fine. Then you get times 2. Okay.
Yeah.
Got lucky. Okay?
Okay.
Yeah. Okay, then part 2. Wow, if it's luck, then does it mean the other questions also based on luck? I haven't checked. Should I check? I will check it. Okay. Continuous random variable x has expectation x equals 0, variance x is 4/5. Sorry, I'm checking back the previous questions that you got correct. Okay, maybe I'll just check one. I'll check the rest and get back to you eventually, I guess.
Oh, okay.
Then yeah, I'll just check question 11 since I started. Continuous random variable x has ex equals 0, variance x equals 4/5. Random variable y is defined by y equal to ax plus b. A and b are positive constants. Given the expectation of y is 50, variance of y is 80, find the value of a and b. Expectation of y, substitute y with ax plus b. Split it up because of linearity. What do you write here? I cannot read. Nemo like.
Oh no, I just put memorize.
Oh, sorry. Okay. Yes, correct. You just have to factor out the a and split up into a sum. So it's very similar to differentiation, okay? Like for example, 2x power 7 plus 3x. You can split it up as 2 times derivative of x power 7. Okay, maybe this one I don't put 3 as I put maybe ln x. Then plus derivative of ln x. Can you see the similarity? The differentiation it's a bit like expectation. A times x plus b. 2 times x power 7 plus b ln x. Can you see the pattern? Who goes out?
Not really.
Cannot see the pattern? Wait. What? Okay. Wait. I color code it. Blue color and green color. Can you see?
Yeah.
Blue color and green color. Then you can split it up as derivative of the blue part plus derivative of the green part. Then when you differentiate the blue part, the factor 2 can the coefficient 2 can be factored out. So you're left with 2 times of derivative of x power 7 plus derivative of ln x. Right? You know this, right? This is natural to you, no? That's
yeah.
what you're supposed to do lah. When you're differentiating term by term, right? Differentiate 2 times x power 7 means you leave the 2 alone, then you differentiate x power 7 and you multiply. Then plus ln x is a separate term. That's why you differentiate a separate term. That's how you do it, right?
Yeah.
So you should see the pattern that a number times some variable, you can factor out the number, right? Factor out the number from the d by dx. Say it's just like when you're doing like a differential equation or the Maclaurin series, all that questions. Same thing over here. Ax, you can also factor out the a. Expectation of ax plus expectation of b. Then you can factor out the a. It's just that in this case, expectation of b is just a constant. Expectation of b is just b. Okay, can, yeah, then you just memorize also okay lah, I guess. Just make sure you don't have any too difficult questions appearing in A levels. If not, you don't know how to adapt. Linearity. The basic idea is you got x plus y plus z like this. You can split it up as ex plus ey plus ez. And if you have expectation of ax plus by, it will be, what will it be equal to?
Aex plus bey.
Yes, exactly. Well done. You know what? Okay, don't worry so much. You know this. Okay. Moving on. So substitute the ex with 0, then a times 0 is 0. 0 plus b is just b. So that's it's just b. So b on the left hand side. 50 remains all the way as 50. Because that is expectation of y. Okay, then b equal to 50. That's fine. Then you use variance x equal to 4/5. So you go and substitute the hold on. Variance ax plus b is really just variance of y, right? So maybe you should write down variance y here. Then you can factor out the a, become an a square from the ax, and then you should split it up first. Variance ax plus variance of b. Then variance of ax, you can factor out the a, so it's a square times variance x plus variance of b. But of course, variance of b, you can just drop the constant. A constant doesn't affect your variance. Okay, then after that, variance of x can be replaced with 4/5. 4/5 equal to 80. Why? Oh, because it's variance of y, which is given to be 80. Then from there, you can bring the 4/5 over and then you solve for a, take a square root. Now, you say that a is more than 0. Yes, because it's positive. So you don't need to take the negative 10. So you got a equal to 10 and b equal to 50. Okay, good. Okay, then a random sample consists of 160 independent observations of y. Find an approximate value for the probability that the sample sum lies between 7840 and 8080. Okay. Sample sum. Okay. 160 independent observations. Oh, okay. I guess you need to use a sample mean here because of the approximate value. What else could you possibly do? You can't really do anything, so you should start with okay. Can I just clarify your English here? The random sample be denoted by y bar. That's a misconception. When this is not the random sample itself. It's the random sample mean. Do you know the difference?
Yeah.
Very different.
Oh, but I thought they don't check, so I just like.
Yeah, it should be accurate. Here, random sample is the original y. Here, y bar is different already. It's a sample mean. It's different. That's why you had to multiply by 160, right? So that you can get your actual sum. Why is that? Why will you get the sum when you multiply by 160? Why?
Huh?
Why do you multiply by 160 here? Why do you
Because it's 160 independent observations of y.
Oh, then you just multiply by y bar. Okay, what's the definition of y bar again?
The average of like all the observations. Like
So equals to?
like y1 plus like dot yn.
Which in this case n is
n
160 over
like 160.
160, exactly. Do you notice that this is a sum already? So why do you multiply by 160? It's because of the definition of y bar. It's a sum, which is what the question is asking for. But divide by 160, so you just times 160. Is that not how you argued it? Is that what you are thinking in your head?
No. I just thought like that one represented one sample.
Then you multiply by 160 to get the sum of all of them. Not really one sample. It's more like the mean, right? So it's just this guy. It's literally this guy. You add up everything and then you divide by 160. So it's on average one of them. Not exactly one. It's just the mean. Okay. I mean, you could have like value like 2, 3, then 47, and then 50. Then what's the mean of these guys? It's 2 plus 3 plus 47 plus 50 divided by 4. Then this ends up not being any of the numbers inside, somewhere in between. So yeah, it's not one of them. It's just literally the sum of them divided by the sample size. That's why you can times 160, just do some algebra, times 160 over to get 160 times y bar equals to the sum. I think you should think of it that way. Try to remember the definition of a sample mean. Then from there, you can work out what's the sum. All right.
Oh, okay.
Can I just 160 times over? If not, how did you get this in the first place? Intuition? Okay, intuition is not
No,
that.
I thought it represented one.
Represented
only.
one. Oh, then you times 160, you get a total. Okay, no lah, it's not one, it's just the mean. It's just the mean, it's just this guy. All right. It could be none of them because I already explained just now with this example. It's possible that it's not even any one of them. Like the mean here, 2 plus 3 plus 47 plus 50 is, if I just really calculate it, it's 25.5 now. So 25.5 is not one of them at all. It's not 2, it's not 3, it's not 47, it's not 50. So yeah. Just think of it in terms of the formula. Okay, you will have an easier time. Yeah. Then here, actually, I find this question actually a little bit challenging because they did not mention the mean. Usually, you would think they will give you what sample mean, but here they give you sample sum, which is different. Okay, you have to be a little bit creative here to be able to solve this. Sample sum is actually the numerator part of the sample mean. Or you could be desperate. You could think, there's not enough information. They never tell me anything. Oh, then you see 160. Wow, very big. Number very big. Then therefore you think of, when it's large, use CLT. Then you use sample. Then you find the sample mean. That could be the intuition behind this question. Okay, can
Okay.
moving on. Okay, what is the next one? Okay, question 18. Weight of X kg of each student in a random sample of 120 students from a secondary school is measured. There's a summarized data, find unbiased estimate, and population mean. Not gonna check this. I think you got it right. Part 2. Another random sample of n students more than or equal to 50 is taken from the school. Given that the probability of the sample mean weight exceeding 49.9 kg is at most 0.01. So at most means less than or equal, right?
Yeah.
Probability is at most 0.01 of the sample mean weight exceeding 49.9. So in that case, it will be, let's just let a random variable be the weight of one student. So X bar, right, the sample mean exceeding, so strictly more than 49.9 kg. This will be at most 0.01. Find the least value of n. Okay, final answer only. What does that mean?
Like I see the solution, then my working like looks the same. But then I try to key in, then I didn't get the correct answer.
Okay, let's take a look at the solution. Can see the solution?
Oh.
Okay. What is the sample variance though? Could it be that you didn't use the more accurate version? You rounded off already. You use 49.2 and you use 9.03.
Oh, but my
Usually
answer is very different. It's like 99.
Wow, that's quite off. Actually, I'm not sure. Let me double check first. You're working. Oh, let me show the screen. Okay, let's see. Y follows normal distribution. 49.2, 9.03 over n. Okay, yeah, good. This part also. So one important point to bring up is that we don't know the actual sigma square, so we have to replace it with s square. Right? That's what you did, huh?
Yeah.
We don't know sigma square, so we use s square instead. So there was one more point that I didn't bring up. Yeah, here. Use s square if sigma square not provided. Yeah, this is actually quite important. Use s square if sigma square not provided or not available. Okay.
Yeah.
Okay, I'll send you the file later. But this one, anyways, yeah, you did it right. Then after that, this is actually y bar already lah, huh? So, or rather, sorry, it's x bar, But you let y, let the other random sample, okay. Okay, can also lah, huh? If you use y, just need to take note that this is a sample mean. And also you have to say approximately by CLT. Because we don't actually know if it's normal distribution. You see, the question didn't say. The question didn't say normal at all. Since when did they say normal distribution? They didn't say. They only told you that it's n more than equal 50. Okay, so that's why you have they only said that n is more than equal to 50. That's why you can use CLT to conclude it's not normal. So this part is quite important, approximately by CLT. Maybe also, to be more accurate, you can also say when n more than or equal to 50, which is large. Okay. Y more than 49.9 less than equal to 0.01. Yep. Because exceeding, then you subtract and then you divide by square root of that. Okay. Take the inverse norm. I mean double check. Inverse norm. Second distribution, number 3 for inverse norm of what? Of 0.01. Negative 2.326. Right. This is more than right. So you use right tail inverse. Okay. Sorry. Right, it should be 0.99. Okay, my old calculator, I should be using 0.99. Sorry. Yeah, 2.32 is fine. Okay. Then, unless you did an algebra mistake, 49.9 minus 49.2 is 0.7. Divided by algebra mistake. Wrong already. Okay, I give you a simpler question. 5 minus mic test, am I still connected?
Yeah.
Okay, let's pretend that this is the equation. Solve for n. Is it the same as 2 over square root 16 equals 7 times root n?
No.
No, What's wrong?
I thought I didn't do this.
Did you not? Let's see.
Because
Oh,
split up the
right. You
square.
didn't do that. Sorry. Oh, you're correct. Let me see. You brought the square root n on top and then you divided by the fraction here. The square root n you brought up. Then you left it alone. Okay, you're correct. Sorry. Yeah. Let me double check. Divide by fraction 9.03. Oh, could it really be? Maybe it really is the rounding error. Because your answer, I also got the 99.7. I think it's the rounding error. Let me check with their solution.
Okay.
They use 49.167 and they use 9.0308. So, this part here. 2.3263, you use the same level of accuracy. Let me just copy down what they are writing first. Oh, wait, hold on. Let me see. This is question what again? Question
18.
18. Okay. Wait, Can you see the screen?
Yeah.
Yes, okay, can. So what they do? They use the more accurate version. I think maybe it really is a rounding error. Oh, that's very bad. So square root n multiplied by the 49.9 minus 49.167 divided by square root 9.0308. Number is so big, more than or equals to 2.3263. Then you just take this whole thing, you divide over. So you end up with this guy divided by that fraction. Let's see. Then afterwards, you need to square it. 2.3263 divided by that fraction first. And then you square it. Yes, it's a rounding error. Okay, it really is a rounding off error.
Huh?
Yeah.
I didn't know it affects so much.
Yeah, I guess so. Because the numbers we're working with are decimals already. Yeah, so 91. Okay. Yeah. Wow. Use a more accurate answer. 5SF. Intermediate working anyways, 3SF is not good enough. Usually we will want 5SF. 5 significant figures as a intermediate step. Intermediate working.
Okay.
You never use the rounded off 3SF answer. Like here and here, you lost too much accuracy already. Okay. Can next 19. Okay. Is it correct? I'm not gonna mark it if it's correct. The ones you circled. Let's just zoom in. Okay, let me read first. Fruit seller, they grade the apples according to their mass. It is given that the mass of randomly chosen apple follows normal distribution with mean mu grams and standard deviation 30 grams. Apples with a mass exceeding 150, large. Mass less than 70, small. Proportion of large apples is the same as proportion of small apples. Explain why mu is 110. Or just take the average of. I think you drew a graph. Yeah, 70 and 150. Just take the average, 110. Okay, good. Part 2 is find probability that total mass of two randomly chosen apples exceeds 230. So it's x1 plus x2 usually. You want it more than 230. Did you do that? Okay. You just let a new random variable x be the total mass. Can also. That works. And just add them together and you'll get your expectation and variance. More than, then you can solve. Okay. Part 3, find the probability that a buyer who picks 50 apples randomly will have at least 3 apples which are graded as large. So this one should probably be binomial distribution. You see 50 must be sample size. At least 3 apples is, so let's just say that at least 3 apples means some x more than equal to 3. So x must be a random variable that represents one such apple being something. Being what? Being graded as large. So this is your success event. The failure will be the complement, which is not large.
Yeah.
Right? And it's a fixed probability, right? Each time you pick a tree, I think it's safe to assume it's independent. Yeah, should be independent. You pick, okay, maybe if you start thinking of the biology and ecology, maybe there's some effect. But you don't need to think so hard, just pretend it's independent. So it will satisfy all the requirements to be a binomial distribution. Therefore, you can just say let x be some random variable for the number of apples out of 50 which are graded as large. Just copy the question.
Yeah.
Then x follows binomial. How many? 50. What's the probability? Probability that you are graded as large. So did we calculate that already?
No.
Part 1 or part 2? No.
I thought it was half. Because you see the proportion is the same.
They gave you a normal distribution here already. Let's just call it M. M for mass, follows normal distribution. mean is mu, variance is 30, standard deviation squared. Oh, then they want what? They want graded as large means more than 150. So it's probability of n more than 150. You need to go and calculate it. Right? And we already found out that mu is 110.
So the proportion the same, doesn't matter.
Proportion is same. It matters in helping you to explain why mu is 110, but then no, it doesn't. It's not 50, it can't be 0.5. 0.5 means what? Means this area here, half of the entire graph. Right? 0.5. Or it could be the other left half. That doesn't make sense. Right? This is definitely less than half. Oh, definitely less than 0.5. So you don't give that as an answer. Half is wrong. Yes, why not half if the proportion is equal? Proportion is equal because proportion is equal doesn't imply it's half and half. They don't make up the entire graph. There's also other percentage here. Maybe this one only 10%, 10%. Then there's the other remaining 80% in the middle. That's more than 70, but less than 150. Not, yeah. Medium size maybe. Okay? So basically you're on the right track. It's just that this part here is not 0.5. You need to calculate P of n more than 150. M being the normal distribution, mean 110, variance 30 square. Okay? Then after that, you can calculate P of x more than or equal to 3. I'm sure you know how to do that. Yeah, binomial. Just rewrite it as 1 minus P of, is it x less than 3 or is it, okay, can I put down less than or, can I put down less than 2? Can I put down less than 2?
Cannot, then you will exclude 2.
Yes, correct. Because more than or equal to 3, opposite will be not 3. Don't want 3. So the next best number is 2. You need to include 2. Okay. Yeah, then so on and so forth. You know how to do the rest. Do I need to go through?
No.
This guy is P of m more than 150. Okay, I'm gonna skip. Okay, then part 4, is it okay? Average cost of apple, 2 oranges.
Yeah, I think I did. I did corrections.
Oh, can understand huh?
Yeah, because I didn't do it like gram by gram.
Oh, you can change the scale. We will still get the same answer. Should be okay, but then what do you want to do instead?
I just times 0.2
times
to 110.
110? We got 110. Oh. Then that's a wrong scale, right? Let me read the question. 0.2 per 100 grams. Where do you get 110 from?
The mass of the apples.
Average cost of one apple. Okay. Average cost.
Yeah, I initially times like 0.2 to the 110, so it like didn't make sense because it's not like per gram.
Yeah,
So
it definitely doesn't make sense, because what does it mean if you just draw a quick diagram like this? 100 grams is 20 cents. You want 110 grams, you times 110? Wow, that's a bit expensive. You only times 1.1, right? 100 go to 110. It's not times 110, it's just times 1.1. If you want to keep the 0.20 also okay, but you must make sure you change to 1.1. The scale must be correct. Is that okay?
Yeah.
It's equivalent to going to 1 gram first. Then you get the 0.002. Then after that, you times 110. Same thing. It's just rate. Like primary school stuff, maybe secondary school. Is that okay?
Yeah.
Huh? Scaling it, the higher the mass, then the more expensive the price. Like direct proportion, right? Y equal to K times X. Yeah. Okay. Can you understood the solution? Do I need to go through?
Don't need. It's just the initial part.
Okay, can. Then I want to go through with you hypothesis testing, just a quick one. Let me find your worksheet from many months ago. Many weeks ago. ASRJC. Okay, where is the hypothesis testing? You remember this worksheet?
Huh?
From May. You did it in May.
Oh yeah, I think so.
Drone
What?
carrying a bomb. Wow. This one. Missile launching to intercept drone. Okay. Let me find I hope it's like if you go and redo the paper, I hope it's easier now. No.
I
Yes.
haven't tried it.
Yeah, you should try soon some prelim papers. Should I assign? I don't think I want to. You can do on your own. I will just go according to the topic. Let's look at the question 8 again. So maybe if I just scroll down. All the way. Wow, this is very far. Have you read all this?
From last time.
Yes. I sent you already.
I probably forgot already.
Spend so much time on this. You never do it. Okay, fine. I will go through now. Let's take a look.
I will read it later.
Yeah. Do you need me to send it again? I'll send it in, I believe, in May. Okay. Let me just modify this to make it look nicer. Like this. Okay, so here's the question. Let's read the question together. So the boss of a hair salon claims that the waiting time on average is 15 minutes. Jeremy believes that the waiting time quoted by the hair salon chain is understated. So he doubts the claim of the boss. He wants to prove him wrong. So he wants to do an experiment. Then he collect data. Then of course you have to do a hypothesis test to prove that his statement is true or false. Okay, so he carries out a survey to investigate this by asking the waiting time of 110 customers. He is very persistent. He wants to prove the boss wrong. The waiting time are summarized by the following. Sum of t equals 1900. Sum of t minus 15 bracket square equals 25400. Find the unbiased estimate of the population mean. So this one is simple. Population unbiased estimate of population mean is just mean. Okay, just divide. But here it's not x, it's t, or ti. In this case, we already got a sum, which is 1900. We got 110 customers, so it's just 1900 divided by 110. Right? Easy, huh? Okay, good. The solution is already written here. Good. Moving on. Let's look at the other half of part 1. Show that the unbiased estimate of the population variance is given by this value 227.815. So how do we do it?
Just
so again,
minus formula.
Correct. You must use the x minus a version. So x minus a square minus a sum of x minus a, bracket the whole thing, then square over n. No square around over the n. There's no square in the n. Okay, so yeah, here you need what? What is the key thing that's missing?
The minus 15.
Here, from the sum t. Great. Of course, it's not x, it's t. So what we need now is sum of t minus 15. What would this be? Sum t minus sum 15. Sum t is what? 1900. Sum 15 is what? It's just a short form for I equals to 1 to the sample size 110. So this is really just 15 times 110.
110.
Okay, calculate that. What do you get? Let's see. Then you get 250. Then after that, you can just sub in. So it's just 1 over 110 minus 1. You can simplify to 109 straight away. Sum of x minus 10 bracket square is t minus 15 bracket square 25400. Subtract away bracket square over n is 110. Sum x minus a is 250. Okay, I've written it over here as well. Okay, yeah, the alternate formula. Yeah, I also gave a long-winded explanation for why you should be using. What's the problem here if you try to use the original formula? You need the x minus a instead to speed things up. Okay, must remember this. Very important. Not provided in MF26. Need to memorize yourself, or at least just sub in with minus a on your own. Okay.
Okay.
Yeah, use calculator, you get the 227.815, which was required by the question. Right, 227.815. Okay, good. Part 1 done. Let's move on part 2. Now carry out a test on Jeremy's belief that the 5% significance level, stating a necessary assumption for the test. So this is your alpha already, alpha 5%. Okay, so I want to go through with you hypothesis testing the procedure in case you forgot.
Yeah.
So did I write it down? Yeah, I wrote a very long-winded version. So here is the shorter version without the details first. Take note that T distribution is not tested. If it sounds unfamiliar to you, T distribution, good.
Yeah.
Just ignore it.
Okay.
Okay. 6-step procedure. Step 0 first, you have to define the appropriate variables in the context. So like, for example, you need to let X be the random variable for whatever. Sometimes it's not X, it's X bar. Usually it's X bar actually. Okay, next, we want to talk about step 1. Define your H0 and your H1. What do we call them? What hypothesis?
The null hypothesis.
H0 is the null hypothesis, then H1 is the?
Like test.
Or
alternative hypothesis.
Yes, alternate hypothesis. Please remember that. Okay, then determine the alternative law, what's the opposite. Okay, then step 2 is to determine the appropriate test statistic and its distribution. Okay, this is actually in general, but for the purpose of H2 math, you just need to remember distribution just means normal distribution. In the future, you'll learn about if you're studying social science or if you want to study science or engineering, you will need to learn about other kinds of distribution. H2 math, just no normal distribution can already. Then test statistic, don't worry, it's just your X bar. Then you need to standardize it, so you minus mu divided by square root of sigma square. Don't worry too much about it. These two, I'll go through it later. Then step 3, state the level of significance, 100 alpha %. That's just a fancy way of saying 5%. Okay, 100 alpha %. Level of significance, that's your 5%. Remember, 5% is like on your graph, you have a area here that's 5%, right tail area. Then you have a certain data. It could have other %. Then depending on its relationship with the 5%, we will determine whether we reject H0 or we accept H0. Okay? Can yeah, 5% is like your what do you call the boundary, your limit. Okay, so like for example, why do I say 100 alpha here? Is because if alpha is like 0.05, that means that 100 times alpha % will be 100 times 0.05%. 100 times 0.05 is 5, which means this is 5%. Okay, so 100 alpha % is the formal way of saying 5% when alpha equals 0.05. Level of significance. Okay, then for step 4, there's like 2 methods. Now you want to find method 1, value of the test statistic. Also known, sometimes we also call it the quantile value. Then method 2 is to find the value of the test statistic and the p-value. Okay, method 1 requires only one something, method 2 requires 2 things, but usually method 2 is easier. Okay, then I continue explaining. You know what's p-value, huh? No?
Oh, yeah, like the probability.
Yes, the probability. Okay, just the area under the curve. All right, then next one, number 5, we have to compare. Step 4 was fine. Now step 5 is to compare. Compare what? Let's focus on method 1 first. After you found the test statistic, you have to compare the value of this test statistic with the critical value. You know what's critical value?
Like if it lies within that region, then it gets rejected.
Yes, correct. So it's an interval. So basically, if you try to inverse norm, you will get some number here. Inverse norm, like x equals to some critical value. You inverse norm what? Inverse norm the 5%. So area 0.05. The alpha, the 100 alpha percent. Okay. If you inverse norm that along with the 0, 1, you will be, I think it should be 0, 1. Yeah, then you'll be able to obtain the x coordinate here. The x coordinate of this, or rather the equation of this vertical line, x equal to something. That something is the critical value. Okay. Then you're supposed to compare your test statistic. Is it to the left or to the right? In or out of the critical region. Okay, so in this case, critical region, right, it depends on the type of H0 and H1 you have. If it's if your H1 is testing mu to be more than, then it's a right tail test. Mu to be less than, it's a left tail test. Mu not equal, then it's a two tail test. Do you know what those things mean? Right tail, left tail, more two tail?
Yeah.
We'll see later.
Like,
okay,
like press the GC.
Press the GC, yes, choose the correct direction. Okay, can. Then that is method 1. So if you're inside a critical region, then do something. Outside, do something else. And hence critical region. Okay. Yeah. Compare value of test statistic with critical value. Then next one, number 6. Write the conclusion in the context of the question. I'll explain later. Then for method 2, let's just finish up first. The method 2, the first step was find what? Find value of test statistic as well as p-value. Then after that, method 2, continuing on, you have to compare p-value with alpha. Do you know how to compare this one? This one is, instead of looking at critical value and the test statistic value, you compare area with area. Just now was x with x coordinate with x coordinate. Now it's area with area. P-value is the area under a curve. Alpha is the 5% right tail area under the curve. Usually, it's not always right tail, but yeah. Does it make sense? The p-value style?
Yeah.
Yes, huh? Okay, good. Then now we can look at an example. The details. Haha. Determine appropriate test statistic and distribution got like 4 cases. I'll leave it to you to read on your own. Ha 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 ha. Go and read. Then let's just look at the answer for this question. Wait, before that, let's read the question again. Carry out a test on Jeremy's belief at the 5% alpha. Okay, I shouldn't say that. I should just look at that 5%. The 5% significance level, stating a necessary assumption for the test. 5% is 100 alpha percent, where alpha is 0.05. Okay, so let's see. How do you do it? Now, remember the context of the question. Can I just bring the question down first? Hold on. Remember the purpose of Jeremy. What is he trying to do? He's trying to, the boss is saying, no, our waiting time very little. But Jeremy is saying is saying, no, the waiting time is definitely more. So that means that the alternate hypothesis should be more than what is claimed by the boss. Does it make sense? The direction?
Yeah.
Jeremy, you are thinking in the point of view of Jeremy. Jeremy wants to show that the boss is sort of lying about the quality of the service. The waiting time is actually way, way, way longer. That's why it's more the alternate hypothesis. Make sense? You're going
Yeah.
against the boss, so you must go more. So that's why this is a right tail test. Okay, can now. Then yeah. So let's continue. So step zero, step zero is defining the appropriate variables. So what they have as appropriate variables, they say let mu be the average waiting time of a customer, then let t be the random variable for the waiting time of a randomly chosen customer. Okay, can. Then mu is always chosen. In H2 we always do hypothesis testing on the mean. So in this case, the mean average waiting time. Okay, so now we want to test H0 versus H1. H0 is the boss's claim. Oh, only 15-minute waiting time. But then H1 is Jeremy's claim. No, it is more than 15. Is that okay? I rewrote it here in pink so that it's clearer. Can?
Yeah, can.
Step, okay, this is your step 1, define H0 and H1. Now step 2, we want to determine an appropriate test statistic and its distribution. So we are almost always, we are only doing a Z test. And here it's a right tail test. Okay. At how many percent level? 5% level of significance. So this is step 2 and step 3. Just sort of combined into one. Okay. Step 2 and step 3. Combined into one. Okay, this is more of step 3, where you state the level of significance. But for step 2, if you remember, you are determining an appropriate test statistic and its distribution. You would usually be looking only at the sample mean. Okay, so T is random variable for waiting time, right? But we don't focus on waiting time. We look at the average waiting time. Yeah. Yeah, because you see, the boss's claim is what? Waiting time on average, right? So that means Jeremy's counter must also be focusing on the average waiting time. So it's not T, but rather T bar. Does it make sense? It's always the case. It's always bar and T bar. Hypothesis testing. In H2 Max, we only do hypothesis testing involving the mean, population mean.
Okay.
So it's T bar.
Because
Then,
it's mean, so it's the bar.
Yes, correct. So T here is the initial random variable, but then afterwards you need to find out T bar. And what's the magic theorem we have involving the T bar? Central limit theorem. Okay. You have to say that since the sample size 110 is large, then by CLT, T bar will follow a certain distribution. This is what I was saying a few times in step 2, determining an appropriate test statistic and its distribution. So over here, the distribution will be what? 15,227.815 over 110. Okay, I rewrite it here. Where do we get these numbers from? 15 is the, or rather, if X follows some question mark distribution with mu, comma, sigma square, by CLT X bar will follow normal distribution. What's the mean?
Or the mu.
What's the variance?
The sigma square over 2. Over the n.
Over n. Okay, good. This is approximately by CLT when n large. Okay, so now, can you see what is your mu? 15. Where did it come from?
From the question.
Yeah, everything also comes from the question lah. More specifically, which part of the question? It came from this guy here, right?
Yeah.
15. Who said 15? Who claimed it's 15 minutes?
The
H0, okay? H0, which is the boss. The person that we are trying to fight against. Can you remember?
Yeah.
Not Jeremy. Jeremy is the guy who's going against. This is the one who is being who's we're trying to show is lying or something like that. Okay, not sure if it's lying or not. Well, we have to do the test to figure out. So 15 is from that mean. And it's anyways, I've also written mu equals 15 here. So mu is also written over here. I wrote down a few times, so it should definitely be the same. Then how about the other guy, sigma square over n? Where did sigma square come from? This 227.815. That's when you must remember the other point I made. Use s square if sigma square not given, right?
Yeah.
And so in this case, yes, indeed, the sigma square is not given. So that's why we use 227.815, which was from here, the unbiased estimate of the population variance, the S square. Sigma square is not known, the population variance, so that's why we use the unbiased estimate of the population variance. Okay, this is an unbiased estimate. Okay.
Yeah.
I know in H2 unbiased is not defined. What does unbiased mean? You don't need to know. You just need to know that where it's S square and it involves some funny 1 over n, not n, but rather n minus 1, and so on and so forth. Just use the formula.
Oh, okay.
Okay. To understand it, that's what that one is for the math already. Don't need. No. Okay, moving on. So then you just divide by n, because of the formula. But here, instead of sigma square, it's a S square. Okay?
Yeah.
And good. So now from the GC, you get a p-value 0.0571. Okay. Then after that, we can, now we are using method 2, step 4. Find the p-value. Then after that, step 5, we want to compare this value of the the p-value with the alpha. Okay. So alpha in this case we know is 5%, so 0.05. Then since the p-value is more than this 0.05, we do not reject H0 and conclude that there is insufficient evidence that the mean waiting time is more than 15 minutes at 5% significance level. Okay. There are only 2 ways to phrase it. 2 correct conclusions. Did I write down? Okay, I should write this down. Where did I write this? Later, then I explain how to use GC. Later. No space already. How should I squeeze this in? I'll send you this file again later, because I wrote down on here already. So there are only 2 correct ways. You either reject H0 or you do not reject H0. Take note that not rejecting H0 does not mean you accept H0. Okay. Have you heard of this idea of what is it called? What was that thing called? Karl Popper.
Huh?
Karl Popper. Who is Karl Popper? Okay, it's a philosopher who came up with all this idea. I think it's called the idea of falsification. Yes, correct. Falsification. So basically, you are, I might be butchering this, but basically the philosophy behind hypothesis testing is that you can either you cannot assume anything is true in this world. You just reject everything. The only thing that you can do is to show that something is false. Okay.
Oh.
Something is false. Like in any scientific claim, right? You just assume that it may not be true. Then the goal of a scientist is to constantly doubt whether it's true or not. Okay, of course not. You have to believe at some point. You just to really do an experiment. You're making a claim, a hypothesis, and then you're trying to disprove the claim. If you fail to disprove it, not reject H0, it doesn't mean that you accept it. It could be that you have yet to find one experiment that is good enough to disprove the claim. You haven't found enough evidence to disprove it, maybe. But then some things are like the law of gravity or F = ma. many hundreds of years, people have tried to disprove it. It has failed to be disproven. We did not reject H naught. Then at some point, some guy decides, okay lah, since we cannot reject it for so many years, we'll just assume that it is true. So we accept it.
Ooh.
This may be biased. Not rejecting something, is it the same as accepting it?
No.
Not exactly, yeah. Yeah, not exactly. It could be that you're just not, you're still doubtful about it, you're still suspicious of it, but then you just fail to gather enough evidence to show that thing is false. Okay, but anyways, just how to conclude, how to reject it. Here's how you phrase it. You either reject H naught or you do not reject H naught. Don't talk about H1. Don't talk about H1. You reject H naught at the alpha percent level of significance. So it's usually 5% or 10% or maybe even 15%. Or wait, 15 a bit too much. 5%, 10%, or maybe 1%. 1%, 5% or 10%. You read the question. Level of significance and conclude that there is sufficient evidence that H1 is true. You only talk about H1 at the back. Then for the rejecting H naught, it's the exact same thing at the alpha percent level of significance and conclude there is insufficient evidence. That H1 is true. Okay, those are the only two conclusions you can make.
Okay.
Okay, can. Okay, then now how did I manage to calculate this value here, the 0.0571? So let's scroll down to the procedure here. Okay. Z-test, just Z-test. Okay, let's see. On the GC, press that. Right. Go to test. You see Z-test, you select. Okay. Then after that, input must change to stats. Enter. Wow, then everything reset. What do you do now? Key in the correct values. So now what is the mu? I cannot remember. Let me scroll up. Over here, T bar. What's the mu? 15. What's the sigma? Sigma is standard deviation, right? So it should be square root of variance every time. Square root variance. So what's the variance here? 227.185 divided by 110. Okay?
Yeah.
815. Did I say wrongly? Sorry. Sorry, what did I click? Press enter too fast. I should just press down. Okay, lucky it's still safe. Then X bar. Oh, memory is insufficient for calculation. Did I do something wrongly? Let's see. Oh, hold on. What did I do wrongly? Okay. Oh no, what happened? Can you see? Do you know what I did wrongly?
No. What is the sigma value again? Let me think a bit. Did I
This is a right tail test, right? Mu is 15. Let me think of it. C test. Oh, right. Sorry. This sigma, you're not supposed to include the n. Yeah. That's right. Sorry. Okay. Let me go here again. So what do we currently have? We got 227.815 over 110. This is sigma square over n, right?
Yeah.
So here the sigma is not the square root of this whole thing. It's just the square root of the numerator.
Oh.
Right. Because
Yeah.
n is 110. Sigma square is square root of the numerator only. Sorry. Yeah. Always forget this one. Okay. 227.815. Enter. Whoa, what's going on? Hey, is it still wrong? Let me see. Something wrong. Oh my. Or should it have been a left tail test? Okay, I am a bit confused already. I'm so sorry. Give me a moment to check this out.
Okay.
Insufficient memory. Okay. Let me see this. Unless sorry, give me a moment to check this out.
Okay.
Sorry for the delay. Let me check first. Okay, I think there's a problem with my calculator. Okay, that's a problem with that other GC. Hold on a second, let me share the screen. Sharing in a few more seconds. Okay, can you see the other GC?
Yeah, can.
Yeah, I need to use this one. I don't know how to squeeze it so that it looks a bit nicer, but yeah, you have to accept the screen separated like that. So let's take a look. So if you press stat, then you go to test. Okay, you reach Z test, press enter. Then you have to, originally you will be at data. You have to scroll to the right to stats. Okay, enter
Oh,
there. Then you press down. So for the mu naught, what is this mu naught? It is just the 15. So let me just zoom in. Recall that T bar is what? T bar is mu, comma, sigma square over n. So the mu naught is actually referring to the mu 15. All right, I keyed it in ahead of time. Then sigma here 15.09 blah blah blah. What is this value actually? It is just the square root of the numerators. Because if you look over here, 227.815, it is the same as our sigma square. So to find sigma, you just take the square root of that. 227.815. Let me just demonstrate it live in case you don't believe. 227.815. Enter. Okay, 15.093 something something. All right, then the X bar 17.273. Where do we get this from? Where do you get this from? You have to go back to your question A part 1 and realize that the X bar is actually referring to the unbiased estimate of the population mean. This fellow. Okay. Where do you get it from? I mean where and we have already calculated it from before here. Right? And I'm just using all the 3 decimal place value, 17.273. Okay?
yeah.
That's your X bar. Okay, you need to do a bit of calculation for the X bar. Then finally, N is 110, the sample size. If you recall from the question, 110 customers. Okay?
Yeah.
Yeah, then this is a right tail test because Jeremy is trying to show that the salon takes more time than 15. So right tail test. And then finally you go down and press calculate, enter. And there we go, finally. Look at the focus on the P, 0.057116961. P equals third row. All right, so is it the same as answer? Yes, it is the same, 0.0571. Okay.
Oh, so what was the problem just now?
I think that other calculator, I couldn't key in a square root. They gave me an overflow. I am not so sure. I will get back to you on that. Maybe I have to migrate to this new calculator for statistics. Yeah. Okay, that shouldn't have been a problem. Yeah. All right, then that will be how to do the hypothesis testing. Then since you have learned it already, you are able to do all of the others, all the other questions already. Practice. The tutorial should be okay already. This you just need to see one example, it should be fine. The key trick here is to remember where to key in what in the calculator. Right? And it requires and you realize that while keying into the GC to get a p-value, right? You had to remember that you have to remember CLT. You have to remember that you need to define a new random variable here, appropriate random variable. And then after that, you find T bar. Then from there, you figure out this guy. Then from this mean, this mu and sigma square over n, you need to remember you're focusing on mu, you're focusing on square root of this fellow, which is the sigma, when you're keying in your into your Z test. Right?
Yeah.
So sampling is a prerequisite to hypothesis testing. You need to know your sampling stuff. But and you have demonstrated that you know most of them. So you can go ahead and do your hypothesis testing tutorial. That will be all for today.
Okay, you'll be sending me this file, right?
Yes.
Okay, can.
Okay, that's all. Bye bye.
Okay, thank you. Bye bye.
Thank you. Sorry for the time wasting.